Hello friends, welcome to Maths Practice. In the last video, we had seen all the key concepts for quadratic equations. I will put the link in the description box. Today we are going to see some very important and different type of examples in quadratic equations. So if you have not subscribed to the channel, please do subscribe to Maths Practice. Practice example 1. The difference of two numbers is 3 and their product is 504. Find the numbers by solving the quadratic equation by method of factorization. Remember, method of factorization, we find the factors of the given quadratic equations and equate each of the factor to 0. Now the difference of two numbers is 3. So if the first number is x, let the second number be x minus 3. Their product is 504. So x into x minus 3 is 504. So we get the quadratic equation x square minus 3x minus 504. Now important thing is you have to get the factors of 504 so that the difference is 3. So you can try different combinations, and as we have seen over here, 24 into 21 is 504. So we have x square minus 24x plus 21x minus 504 is equal to 0. So we get the two factors x minus 24 and x plus 21 equal to 0. Equating them to 0, x is 24 or x is minus 21. So if x is 24, the other number is 24 minus 3, which is 21. And if x is minus 21, the other number is minus 21 minus 3, which is minus 24. So we have the two solutions. The numbers are either minus 21 and minus 24 or 24 and 21. Example 2. Hypotenuse of a right angle triangle is 2 less than 3 times its shortest side. If the remaining side is 2 more than twice the shortest side, find the area of the triangle. Now over here we are given all the comparison with respect to the shortest side. So let the shortest side be x. Hypotenuse, it is given that it is 2 less than 3 times the shortest side. So hypotenuse is 3x minus 2. And the remaining side is 2 more than twice. So 2x plus 2. Now we know the Pythagoras theorem. The square of hypotenuse is equal to the sum of the squares of other two sides. So 3x minus 2 whole square is equal to x square, and another side is 2x plus 2 whole square. Now we simplify this equation. You can see after simplification we get 4x square minus 20x is equal to 0. So 4x into x minus 5 is equal to 0. Now equating both the factors to 0. If 4x is 0 means x is 0. That is not possible because you cannot have length as 0. So only the other option, x minus 5 is equal to 0 or x is equal to 5, is possible. So x is 5, shortest side is 5. The other sides will be 3x minus 2 and 2x plus 2. So the three sides of the triangle are now 5, 12, and hypotenuse is 3x minus 2, which is 13. Now the formula for the area is half base into altitude for a triangle. So half into 5 into 12, which is equal to 30 square units. So the area of the right angle triangle is 30 square units. Practice example 3. Find the roots by method of completing the square for x square minus root 3 plus 1 into x plus root 3 is equal to 0. Now in the last video we had seen that to make the perfect square we can use this formula, third term is equal to middle term square upon 4 into first term. So if we add this third term we will get a perfect square. Now in the given example, middle term square upon 4 into first term is root 3 plus 1 whole square upon 4. But to make it simplified we can multiply the whole equation by 4. So now our equation will be 4x square minus 4 into root 3 plus 1x plus 4 root 3 is equal to 0. Now according to the same formula we get third term as root 3 plus 1 whole square. So third term is root 3 plus 1 whole square. You can also simplify it. It is 3 plus 1 plus 2 root 3, which is 4 plus 2 root 3. Now in the given equation 4x square minus 4 into root 3 plus 1 into x, add the third term to make it a perfect square. So we add root 3 plus 1 whole square. But as we have added root 3 plus 1 whole square, which is 4 plus 2 root 3, and our equation has just 4 root 3, we have to subtract that 4 and 2 root 3. You can verify that now our equation will be same as the equation which we have in the starting. So 4x square minus 4 into root 3 plus 1 into x plus root 3 plus 1 whole square. This is whole square. This is a perfect square. So now it is the square of what? It is the square of 2x minus root 3 plus 1. Okay. So on the left hand side we have 2x minus root 3 plus 1 whole square. Bring the other two terms on the right side, which is 4 minus 2 root 3. Now again, what is 4 minus 2 root 3? It can be written as 1 minus root 3 whole square. You can verify. It is 1 plus 3 minus 2 root 3, which is 4 minus 2 root 3. So now on the left hand side also we have a square, and on the right hand side also we have a square. So we can equate both the squares. So 2x minus root 3 plus 1 is equal to 1 minus root 3, but plus or minus of 1 minus root 3, because you know square means it can be plus or minus. So in the first case, if we take 2x minus root 3 plus 1 is equal to 1 minus root 3, we get in simplified form x is equal to 1. And if we take 2x minus root 3 plus 1 is equal to minus of 1 minus root 3, we get x as root 3. So now we have the two roots as root 3 and 1. Now remember, this is by the method of completing the square. You can also do it easily. If the method is not given, you can do it easily as I have shown on the right hand side. We just simplify the equation and group the terms. So after grouping the terms, we have two brackets which are x minus root 3 and x minus 1 is equal to 0. Just equate them to 0. So you get roots as root 3 and 1. So by factorization, we get the roots simply root 3 and 1. Example 4. Now this is a typical kind of example. If you remember, in linear equations also this type of example was solved. In quadratic equations also you have these type of examples. The speed of a boat in still water is 25 kilometers per hour. In a river it goes 60 kilometers downstream and comes back the same distance upstream in total 5 hours. Find the speed of the current or stream. Note that the speed of the current of river will always be less than the speed of the boat in still water. This is just for information. Now what we have to find is the speed of current or the stream. Let it be x kilometers per hour. Now let us recall and understand some concepts. If the speed of the boat in still water is some a kilometers per hour and the speed of the current is b. Remember, boat is A and the current is B. Then downstream it will go fast. So the speed of the boat in downstream will be more, which is A plus B kilometers per hour. Speed of boat plus speed of current. And if it goes upstream, it will be A minus B, means speed of boat minus speed of current. And one more formula we have, speed is distance upon time, or time is equal to distance upon speed. So we will use this in the solution. Now the speed of boat is given 25 kilometers and we have assumed that let x be the speed of the stream or the current. So according to the formula we have just discussed, the speed of boat downstream, when it goes downstream it will be boat plus stream, means 25 plus x kilometers per hour, and when it goes upstream it will be speed of boat minus speed of stream, means 25 minus x kilometers per hour. Now again, time is distance upon speed. So it is given that 60 kilometers it goes downstream and then 60 kilometers upstream. So distance is 60 kilometers. So time taken for going 60 kilometers downstream will be 60 upon the speed, which is 25 plus x, and the time taken for going 60 kilometers upstream will be 60 upon the speed for upstream, which is 25 minus x. So it is also given that the total time is 5 hours going downstream and upstream, total time. So 60 upon 25 plus x plus 60 upon 25 minus x is equal to 5. Now just we have to simplify this equation. The denominator is 25 plus x into 25 minus x, which is a square minus b square, 25 square minus x square. Now when we simplify this equation, we get x square as 25 or x is equal to 5. Obviously it cannot be negative. So the speed of the current of the river, or you can see the speed of the stream, is 5 kilometers per hour. Now before going to the next example, let us recall some concepts, very important concepts. If you have a quadratic equations ax square plus bx plus c, we know the discriminant or delta d is given by b square minus 4ac, and from the value of d we can decide how many and which type of roots it will have. So d is b square minus 4ac. If d greater than or equal to 0, we know that the roots are real. If it is less than 0, means no real root will exist. Now if it is exactly greater than 0, if d is greater than 0, the roots are real and distinct, and if d is equal to 0, the roots are real and equal. We will recall the quadratic formula. For a quadratic equation ax square plus bx plus c is equal to 0, we have delta d as b square minus 4ac, and the roots are given by x is equal to minus b plus or minus root delta upon 2a, or x is equal to minus b plus or minus root d upon 2a. Now we have seen that if d is less than 0, no real roots. If it is greater than or equal to 0, it will have real and distinct roots. If it is exactly equal to 0, it will have real and equal roots. Now if d is greater than 0 and also if d is a perfect square, we know that the roots will be rational if a, b, c are rational. And if d is greater than 0 but d is not a perfect square, then the roots will not be rational. So if you understand this concept, we can easily find the roots. Example 6. The sum of the ages of two friends is 20 years. 4 years ago, the product of their ages was 48. Show that these statements cannot be true. So first let us evaluate the sum. Let the age of one of the friends be x years, and the sum is 20, so the age of other will be 20 minus x years. Their product is 48 years, that means x minus 4 into their product is 48 4 years ago. So 4 years ago the age of one of the friends would be x minus 4, and that of other friend will be 20 minus x minus 4, and the product of both of them is 48. Now we just simplify this equation. We get minus x square plus 20x minus 112 is equal to 0, or we can write it as x square minus 20x plus 112 is equal to 0. Compare with ax square plus bx plus c. So a is 1, b is minus 20, c is 112. We find d, which is b square minus 4ac. So we get d as minus 48. Now remember, if d is less than 0, we have seen that no real root exists. That means the above statements cannot be true. Example 7. Find the roots of the quadratic equation 1 upon x plus 1 plus 2 upon x plus 2 is equal to 4 upon x plus 4, and x cannot be minus 1, minus 2 or minus 4. Now first is we take the LCM and simplify the examples. So after taking the LCM, we have 3x plus 4 upon x plus 1 into x plus 2 is equal to 4 upon x plus 4. Again cross multiply and simplify the equation. So after simplification we get x square minus 4x minus 8 is equal to 0. So compare it with ax square plus bx plus c. A is 1, b is minus 4 and c is minus 8. Find the discriminant d is equal to b square minus 4ac. Here you get d as 48. Now d is greater than 0, so we know that real and distinct roots will exist. But since it is not a square, that means the roots might not be rational. We apply the quadratic formula to find the roots, which is x is equal to minus b plus or minus root delta upon 2a. Just put the values, you get x as 4 plus or minus root 48 upon 2. But you know 48 is 16 into 3. So root 16 is 4. You can take out 4 common into root 3. So it is 4 plus or minus 4 root 3 upon 2. In simplified form, you get x as 2 plus or minus 2 root 3. So the roots are 2 plus 2 root 3 and 2 minus 2 root 3. Example 8. Find the value of k for which the quadratic equation 2k plus 1 into x square minus 7k plus 2 into x plus 7k minus 3 is equal to 0 has equal roots. Also find these roots. Now first thing is we compare with the standard equation ax square plus bx plus c is equal to 0. So a is 2k plus 1, b is minus of 7k plus 2 and c is 7k minus 3. Now it is given that it has equal roots, means what should be the value of d? D should be equal to 0. So d is equal to b square minus 4ac equal to 0. Put the values, we get in simplified form, simplify the whole equation, we get in simplified form minus 7k square plus 24k plus 16 is equal to 0, or take out minus 7k square minus 24k minus 16 is equal to 0. So now we have got this quadratic equation, we just factorize it. So we can write minus 24k as minus 28 plus 4. On simplification, you get k minus 4 into 7k plus 4 equal to 0. So now you have two factors, equate them to 0. So k is either 4 or 7k plus 4 equal to 0, means k is minus 4 by 7. Hence the values of k are 4 or minus 4 by 7. Now we have already got the values of k as 4 and minus 4 by 7. Now we also have to find the roots for the equation. Again the formula for finding the roots are x is equal to minus b plus or minus root d upon 2a. Now if the roots are equal, means d is equal to 0. So directly you can write as putting d0, you will get x is minus b by 2a. So remember, whenever it is given d equal to 0, you get the root by minus b upon 2a. So in the original equation, we know that a is 2k plus 1, b is minus 7k plus 2, and the equal roots are x is equal to 7k plus 2 upon 2 into 2k plus 1 by minus b upon 2a. So now we have got the equal roots. In the equal root, x is equal to 7k plus 2 upon 2 into 2k plus 1. Put 1 by 1 both the values of k. So if k is 4, your x is 5 by 3. And if k is minus 4 by 7, it is 7. That means if k is 4, the two equal roots are 5 by 3 and 5 by 3. And if k is minus 4 by 7, the two equal roots are 7 and 7. Next example. A train travels 360 kilometers at a uniform speed. If the speed had been 5 kilometers per hour more, it would have taken 1 hour less. If the speed is more, time taken is less. Find the speed of the train. Remember, we are doing all the typical type of examples which can be asked in quadratic equations. Now this is one of them. So we have to find the speed of the train. Let the speed be x kilometers per hour. Now we know speed is distance upon time, or time is distance upon speed. The distance is 360 kilometers. Upon the speed is x. Now if speed is increased by 5 kilometers per hour, so time is equal to, distance will remain the same 360, but speed will become x plus 5. So time is equal to 360 upon x plus 5 if the speed is increased. So we are having both the times. And it is also given that the difference in time is 1 hour. So the more time will be 360 upon x when the speed is less, minus 360 upon x plus 5 when the speed is more. The difference between both the time is 1. So now we just simplify the equation by taking the LCM. We get x square plus 5x minus 1800 is equal to 0. Now you just have to factorize this equation. You have to get the factors of 1800 such that the difference is 5. So you have to do it by trial and error. 1800 you can write the factors and we get it as 45 into 40. So now when we have this equation, we find out the factors. The two factors are x plus 45 and x minus 40. Equate both the factors to 0. So we get x is minus 45 or x is 0. But we know speed cannot be negative. So x is 40. Hence the speed of the train is 40 kilometers per hour. Now some assignment problems which will give you more practice. First one, two water taps together can fill a tank in 9 3/8 hours. The tap of larger diameter takes 10 hours less than the smaller one to fill the tank. Find the time in which each tap can separately fill the tank. Now the hint is, if the time for the smaller tap is x, then the part of tank filled by smaller pipe in 1 hour will be 1 upon x. Similarly for the larger tap. Also two taps together can fill in 9 3/8 hours. So in 1 hour it will be 1 upon 9 3/8. The answer is smaller pipe will take 25 hours and larger pipe will take 15 hours. Second one, find the values of p for which the quadratic equation x square plus p into 4x plus p minus 1 plus 2 has equal roots. Equal roots means the value of discriminant d will be equal to 0 and the answer is minus 1 and 2/3. Find the roots of equation x upon x minus 1 plus x minus 1 upon x is equal to 4. And the answer is the roots are 1 plus root 3/2 and 1 minus root 3/2. Assignment problem 4. The sum of squares of two consecutive odd positive numbers is 290. Find the numbers. Now the numbers are two consecutive odd positive numbers. So odd numbers means if one is x, another one will be x plus 2. You will be getting the equation x square plus 2x minus 143 is equal to 0. And the answer is the numbers are 11 and 13. 5. Seema's age at present is 2 years less than 6 times the age of her daughter Rima. The product of their ages 5 years later will be 330. What was the age of Seema when her daughter Rima was born? Now we have to solve this with the help of quadratic equations. So let us assume that the age of Seema is x. Then actually we will get Rima's age as 330 upon x plus 5 minus 5. And the answer for x will be 28. But the age of Seema when her daughter Rima was born will be 28 minus 5, which is 23 years. Sixth problem, find the roots of the equation x square minus 12 is equal to 0. Answer is minus 2 root 3 and 2 root 3. And the last one is a short question. The discriminant of x square minus 3x minus k is equal to 0 is 1. The value of x will be, the answer is 2. Friends, we have seen all different and important examples on quadratic equations. Hope you have understood them. So please do like and share and subscribe to my channel Maths Practice for more such videos on class 10 Maths. Thank you.